This lesson is about finding the roots of a complex number. In the lesson before, we worked on de Moivre's theorem, which is where we raise to powers, and now we're going to find the roots. This can be done in degrees and radians, and the biggest key to the whole thing is that it must be in polar form. So what's happening is we can't use a rectangular form of a complex number. We need to use polar. So here's our formula, and I'll kind of explain it as we go. So we want to talk about the fourth roots of 8i. That means in rectangular form, there's the real part is a 0, and then it's 8i. So that means it's pure imaginary. So we know from this, and they want the fourth roots, so our n is going to be 4. And then we also know that our r value would have to be 8. And my theta, if I plot the point 0.8, that would put me right on 90 degrees. And that's what I need to get started. So when you go to find the roots, you start the counter k at 0, which means we'll stop when we're 1 less than the number of roots necessary. So since n is 4, we'll go to 3. All right, so now if n is 4, we're going to take the fourth root of our directed distance, or r, which is 8. Then we're going to write down the word cis. Then we're going to take our original angle, 90, and divide it by n, which is 4. And then we're going to add a multiple of 360. So it's 360 times k, so that's 360 times 0 over 4. And then if we simplify what we have here, fourth root of 8, that's not going anywhere. Cis, 90 divided by 4 is 22.5. This part would be a 0, and this would be the first complex root in polar form. Then we repeat the process. K becomes 1. So the fourth root of 8 will stay, and then cis, and then we're going to take our original angle again divided by 4. So we'll just rewrite that 22.5 because that stays, plus 360 times 1 divided by 4, so that's 90. So then we clean it up. Fourth root of 8 stays. Cis, 22.5 plus 90. And then we would get fourth root of 8, cis, 112.5. And that's the second one. And then we are going to come back and do k equals 2. So you can kind of see there's a pattern going. Fourth root of 8, cis, 22.5 plus 360 times 2 all over 4. So that means we're going to add 180. So fourth root of 8, cis, 22.5 plus 180. And if you need to show the step, fine. If you don't, it's okay. Fourth root of 8, cis, 202.5. That's 3. And then our last one will be k equals 3. So again, fourth root of 8, copy the cis, copy the 22.5 plus 360 times 3 over 4. So this time, if you follow the pattern, we'll be adding 270 to our angle there. So fourth root of 8, cis, 22.5 plus 270. So 4th root of 8 cis 292.5. And then there's the 4th one. Now, if we would go back and add another, we would be adding 360, and that would put us back where we started. So that's why it always ends up at 1 less. All right, now I'd like to do an example in radians. The first thing we're going to do is shorten that. So 3, so let's see. So 3 cis pi over 3. And we want the cube roots, so this time n's going to be 3. And now we're going to work in radians. So I'm going to start by initializing k at 0. And all this work, you do have to show this just when you're writing it out to show where the roots come from. So remember, cube root of 3 cis. Now I'm going to take my original angle, which is pi over 3, and I'm going to divide by 3, and then I'm going to write the word cis, and instead of 360, because we're in radians, it's 2 pi times 0, and then we divide by our root, which is 3. So this becomes cube root of 3. Now be careful here. Pi over 3 divided by 3 is like pi over 3 times 1/3. So then that's going to be pi over 9, and then that's a 0. So watch your fractions there. Try to be mindful of how we're dividing. Now if we do k equals 1, that's cube root of 3 cis. And remember, I don't have to repeat it. I'm going to carry the pi over 9. Okay, and then plus, we've got 2 pi times 1, and that's all over 3. So now I'm going to add 2 pi over 3 to pi over 9. So pi over 9 plus 2 pi over 3. Use your calculator to do the fractions if you need. Ignore the pi button. Don't press it. That'll make it crazy. And then this becomes 7 pi over 9. And I can't write here. Let's see, 7 pi over 9. There we go. And then our n is 3, so our last one is k equals 2. And then we have cube root of 3 cis pi over 9 plus 2 pi times 2 all over 3. So this time we're going to add 2 pi over 3 to pi over 9. Trying to show the steps, that way you can see how the work should look. And then here, 3 square root of 3 cis, that would be 13 pi over 9. And then that does it. So really, there's not a lot. The pattern maintains, it stays the same. You're always basing it off that original angle. And remember, your complex number needs to be in polar form.